Hello, good days. My name is Nidia King and we are from Group 1, Section 6. So today we are going to present regarding our project, which is to design a bridge. In our project, we have to design a bridge truss based on the existing and possibility to build a self-bridge, and also the phases that included conceptual and also detailed design, which we are using the appropriate application in our calculation. And it is also important to know the classification of the structure according to the stability and determinacy so that a better design can be made according to its purpose. Next one is project background. So in our design, we have chosen the hull truss, which is strong enough since the structure can balance compression and tension, and the bridge is not need to withstand the disproportionate weight. West Ham Island Bridge is our inspired bridge. It is a partially single lane with deck truss and located at Delta, Canada. So in our project, the objective that we want to obtain is to propose bridge layout and design based on the existing bridges, and also we want to apply the structural analysis skills in bridge design. This is the type of truss that we have taken as references, and it is actually important to learn various types of truss according to its purpose and specific function. Theoretically, a truss is actually a structure that consists of members organized into connected triangles so that the overall assembly behaves as a single object. And commonly, a truss is used in construction of roofs, bridges, and towers.
I'm Seraphim Moichawan with matrix number AF210118, and I'll be presenting the layout and design of our project. The figure shows our bridge design, which is drawn using AutoCAD software where all dimensions are in millimeters. Our bridge consists of an assembly of members connected by knots, which creates a rigid structure. Deck and handrail are also considered in our bridge design. The members of the truss are made up of steel, meanwhile the deck is made up of concrete. This is the top view of our bridge design. Top cut bracing is considered to establish the upper edge of the truss where this member is subjected to compressive and bending stress. This is the floor beam of our bridge design. The length for each horizontal and vertical member is 5000 millimeters. In our bridge design, different types of steel profile are used. For chord bracing, quadratic profile 200 is used, whereas for the diagonal chords, quadratic profile 400 is used. Besides, for vertical and top chords, I profile 500 is used, meanwhile for bottom chords, I profile 800 is used. This is the deck of our bridge design. It is made of concrete with density of 2500 kg per meter cube. The thickness for the deck is 150 millimeters. This is the handrail of our bridge design. Our inspired bridge for this project is West Ham Island Bridge, which uses hull truss design. This bridge has a total length of 325 meters in distance and 4.38 meters in height. The bridge was first opened for traffic in December 1909. However, by 1922 it was deemed unstable for public use. Over the years, the structure has undergone refitting and alterations. However, by the end of 2019, major rehabilitations was done for better sustainability.
I'm Doris with matrix number AF210093. I'm responsible to talk about the specification of choice of design. West Ham Island Bridge is an example of most important historical engineering structure in Delta. The West Ham Island Bridge is an unique surviving structure example of hull truss. Furthermore, West Ham Bridge with hull truss connects two islands to enable the transportation to become more easier. Hull truss is a structure that consists of one pin and one roller at the end of the truss. The diagonal of hull truss experiences compression, while the vertical logs experience the tension. Thus, hull truss is a design of bridge that is extremely strong, since the structure can balance compression and tension, so the bridge is not needed to withstand disappropriate weight. Hull truss is a design that can minimize the maximum compression. Hull truss can use the materials effectively, since all the material have been used to their full potential. Hull truss can withstand extreme conditions because it can extend to long distance and can be used in impassable areas like mountain area. Hull truss can carry traffic on its structure. Thus, hull truss is a good design that is safe to be used. Since m plus r equal to 2j for our design bridge, our bridge is determinate and stable for degree of determinacy.
I'm Jovita Tan with metric number AF210088. I will talk about the analysis of our project. First, we calculate the weight of each section by finding the cross-section area and volume of each member. Then use the equation of weight, which is product of volume, density, and gravity constant. The total self-weight of the bridge is the sum of the weight of all sections, which include the truss, deck, and handwheel. So the total self-weight of the bridge is 1320.96 kN. According to British standard, the loading of the bridge for heavy vertical loading is 8 kN per meter plus 200 kN. Therefore, the loading used in the calculation for this bridge is 440 kN. The reaction is calculated by using the equilibrium equation. Then, by using the alternative method, the internal force of the truss is calculated. Next, to calculate the deflection of the truss, the virtual force is determined. The length, cross-section area, internal force, and virtual force is tabulated to find the deflection of the truss at point G. Therefore, the displacement on point G is 24.1091 mm downwards. Then we check the calculation by using software LimPro. The reaction found by using LimPro is same as our calculation, but the deflection on point G found by using LimPro is slightly different to our calculation, which is 2.290528 cm downward.
My name is Christina, matrix number AF0122, and I'll be presenting discussions, assumptions, and the conclusion of this presentation. First and foremost is the deflection that we've calculated. This one is the manual calculation that we got is negative 24.1091 meters, and the result that we got from the LimPro software is negative 22.90528 meters. Now the difference between those two results is 1.204 meters. Next is there are several factors that affects the results. Mainly is one, number of decimal points, and two is the assumptions made. Now, one assumption that we'll be focusing on is the temperature. Because the LimPro software, it calculates along the temperature of design, where it may affect the results as temperature steel composition where temperature less than 400 degrees Celsius reduces material stiffness and produces thermal expansion information. Now, next, other factors that I did not put into the slide is structural stiffness, pre-stress loss, environmental temperature, and concrete shrinkage and creep. They may also affect the deflection of the bridge frames. However, it is quite insignificant. Next is, in order to ensure the bridge truss integrity in terms of safety, it is important for the bridge truss design to be 1. Geometrically stable, 2. Structural analysis whereby the results of the internal forces and deflection from completions is used to evaluate and determine the strength that needs to design bridge. Third one is determining proper load. Is used to specific type of bridge. Mainly, there are 3 types of load that we need to consider. Dead load, which is the bridge weight in general, live loads, and environmental loads. The last one is truss bridge design. The bridge truss type, such as the arrangement and the pattern of the bridge itself. However, considering how we loosely base our report on our Inspired Bridge, we have opted with Hull Truss as it includes vertical members and diagonals that slope up towards the center. The diagonal web members are in compression and the vertical web members are in tension. Next is the assumptions made throughout this entire project. 1. The members are joined together by smooth pins. Second is all loading is applied at the joints. And third, wind factor, which is an environmental load, is negligible. Now, to conclude this presentation, the proposed bridge layout and design bridge based on our inspired bridge, which is the West Ham Island Bridge, has been proven to be able to withstand load of its intended purpose. And according to the bridge deflection limit, the difference of the results that we obtain is negligible, therefore the bridge is safe for live purposes.